This is Tech Math 2, and we're doing section, I don't know, 12.5, 12.5 today. So now we have the issue of, I have some position, I have some velocity, I have some acceleration. And those are linear things. So I can go that way, and I can go fast, and I can speed up. But we also have angular and angular positions, theta. You know, how often do I go around the circle? Omega, angular acceleration, radians per second. And alpha, angular accelerations, radians per second squared. So that's what we're going to be looking at, the things that look like that. And then we have periods, and we said, well, if we have the sine of 3x, then the period is going to be 2 pi over 3. And so that's what the period is. But what's the frequency? If the period is 2 pi over 3, what's the frequency? Well, yeah, frequency is 1 over the period, and period is 1 over frequency. But how does that relate to angular velocity? Okay, so angular velocity, omega, that's an omega in case you're wondering. It's not a W, it's an omega, clearly, is 2 pi, the frequency. Okay, so now if I have something that's sine omega t, and then I ask myself, well, what does that mean? Well, I could have sine 2 pi ft, and that would be the same thing. I could look at it the same way. So we have 60 hertz power going to our houses, right? The AC is 60 hertz. Well, that's a sine wave. Sine wave 2 pi 60, 120 pi t. So if I look at the voltage going to your house, and I say it's a sine wave, then it's in the form of 125 t. And it has some amplitude. What's the amplitude? 171, right? Because that'd be the peak. There's at 69. 169? 169. Because we normally think of it as RMS, and the RMS is 120 RMS. But 120 RMS times whatever we times it by, 160. All right, anyway, enough of that. So now we're talking about simple harmonic motion. So I got this wheel, I got some point on the wheel's going that way, and that point's hitting there, it's hitting there, it's hitting there, it's hitting there. It's moving like a cosine wave. Oh, way to go. There we go, got it. There, now it hit in all those spots. But because it started at 1, it started at a max, it's moving like a cosine wave across there. I could have started it in a different position. I could have started from there, and then I could have said, well, now I'm moving like a sine wave. I could have done that too. If I have a pendulum swinging back and forth, looks like an anchor, I know, but that's simple harmonic motion that's happening there. If I have a spring, and the spring has some weight on it, and it's moving up and down, it's moving up and down in simple harmonic motion. It's moving up and down as a sine wave would move up and down. And the velocity is going to be the derivative with respect to time of that position. And so the derivative of a sine wave turns out to be a cosine wave. So I can do that too. Well, I can't do that yet because I can't take derivatives of sines and cosines until chapter 23. But those things will all come to be. Okay, questions about anything other than life in general? Let's look at problem number 1 and see if I can actually solve it. Problem number 1. A crank is 8 inches long. Starts from the horizontal position 0. Okay, so I got this crank, and it's starting there. All right. I'm hooked onto something here. This is my handle. And I'm 8 inches long. Okay, so I got that. And rotates in a counterclockwise direction. Okay, that's that way. At a uniform angular velocity of 5 revolutions per second. All right, and we're going to multiply that by 2 pi, and we're going to get 10 pi radians per second. All right, so that's my omega, 10 pi radians per second. Plot the curve that shows the simple harmonic motion of the crank handle and find the equation of the curve. All right, so here we go. We start there, and as time goes up, time passes, it goes up and it goes down and it goes up and it goes down, and we see a sine wave. We see a sine wave with a period of what? What's my period? I have 5 revolutions per second. My period is going to be 10 pi. 10 pi. All right, so now I know my period's 10 pi. Okay, now my period is 10 pi, and I know that that has to equal 2 pi over something b, because I'm going to have sine bx over here when I write my equation. So I put that over there and this over there, and I get that my b is equal to 1/5. All right. So now I need a function, equation of the function, and so I'm going to have sine 1/5 x, and then I'm going to say self, what's the amplitude? 8 inches. The crank angle is going to go up 8 inches, it's going to go down 8 inches. Okay, so I'm going to have 8 inches sine 1/5 x. And then my period is going to be 2 pi over 1/5, which is going to be 10 pi. Okay. Are we happy about that? This is even an odd question, too. You can go look in the back of the book, see if I'm anywhere near right. All right. That being the case, we'll move on to number 3. All right. If the rotating wire from example 2 produces a maximum current at 15 amps and 60 hertz, 60 hertz. Graph the resulting equation when theta is pi over 4. Theta is pi over 4. Okay, so now we're going to move back to example 2. There's example 1. There's example 3. There's example 2. Okay, so current is equal to 15 sine omega t plus pi over 4. And so I is equal to 15 sine pi, 120 pi t plus pi over 4. Okay. So what was I supposed to do? If the blah, 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 graph the equation. Okay, so there's my equation. So the first thing I'm going to ask is, what is my period? My period is 2 pi divided by 120 pi, which is 1 over 60. And what is my phase shift? My phase shift is what? 120 pi divided by pi over 4. That can't be right. Is that right? When is this guy 0? This guy's 0 when that goes over there and this goes on the bottom. So it's the other way around. Phase shift is pi over 4 divided by 120 pi. 1 divided by 480. Okay. So that's my phase shift. And is it positive or negative? It's negative, right? Phase shift is negative. All right, so now we're going to plot a sine function with amplitude 15. All right, so plot a, oh, we can't do that. We need the phase shift. Okay, so if 1 over 60, how do I get to 48? That's 8 times as big. 8 times as big. Okay, so we'll mark it there. 1 over 480. And then it's a sine function, so it's going to go up, it's going to go down, it's going to go up, it's going to go down, it's going to go up to 15, it's going to go down to minus 15. And where does it cross here? 160, 1 over 60 minus 1 over 480. And I think it's time to break out our calculator. 1 divided by 60 minus 1 divided by 480 equals, change to a fraction. Thank you very much for not changing to a fraction. Stupid computer anyway. This is 8 over 480. So this would be 7 over 480. 7 over 480. Our time is in seconds. And this guy's amps. Are we done graphing it? Yeah, I think so. All right, so we got the equation, and we graphed it, and we're done. Do we need any more than what we have? Graph the resulting equation. Yeah, looks good enough. Well, we go the other way, right? Well, why would we want to go the other way? Yeah, might as well. We'll go the other way. Well, I ran out of room anyway. Doesn't matter. Okay, good enough? Okay, well, that seems rather boring. Now, the 8th guy has a weight. Obviously, we have to do number 5 because it's an electrical problem again. Okay, so number 5. I have that E, which is voltage, by the way, is E for electromagnetic, whatever, electromagnetic force, right? Cosine omega t plus alpha, right, plus omega, where E is the maximum voltage, omega is the angular velocity of rotation, t is the time, and theta is the phase shift. Graph the resulting equation for 110 volts, cosine 60 t. Oh, zero phase shift. I like zero phase shifts. All right. So there we go. Now we're all set. We need the period. Period 2 pi over 60, also known as pi over 30. And so now all we need is a cosine function. So let's start over there. All right, looks good. We're going to go up to 110. We're going to go down to minus 110. Volts. And now we're going to repeat in one period, so that'd be pi over 30. I'm going to repeat at one period, minus pi over 30, and we are done. All right. We'll go with number 8. A weight is attached to a spring and vibrates 4 vibrations per second. So I got this spring, I got a weight, and it's going up and down, back to where it was, and it's doing that 4 vibrations per second. And an observed amplitude of 3 inches. Okay, so it's going to go up 3 inches and down 3 inches. All right, find and graph the resulting equation beginning at time 0. T is equal to 0. And my angle is equal to 0, which makes no sense at all, but that's okay, we'll do it anyway. All right, so because I start at 0, the equilibrium position, my amplitude's 3, it's a sine function. My phase shift is 0, so I'm going to have a 0 sitting there. So now it's a matter of what is the b that goes in front of the x. So if I have 4 vibrations per second, okay, that means, what's my period going to be? My period is going to be 2 pi divided by 4. So it'd be pi over 2 radians, because they go up and down and up and down. So if my period is 2 pi over b, what is b? 4. All right. So 3 sine 4t plus 0. We write that as 3 sine 4t. Okay, now we got that. Excellent. Now we just do a sine function. And we start at 0, so we're going to go up, we're going to go down, we're going to go up, we're going to go down, up and down, up and down. We're going to go all the way up to 3, all the way down to minus 3. And our period is pi over 2. So there's pi over 2. There's a pi. And there's 3 pi over 2. Okay, now what happens here is that the spring has some potential energy associated with it. And that potential energy is 1/2 k, which is the spring constant, times x squared. It also has some kinetic energy associated with it. The kinetic energy is 1/2 mv squared. So the total energy of the system is going to be the potential energy plus the kinetic energy. Now, the kinetic energy is going to be max as I'm passing through the equilibrium. The kinetic energy is 0 as I get to the top and I change directions. So my kinetic energy is max when I'm at the 0 positions, when I'm top or bottom, and my kinetic energy is max when I go through there. And its sum has to be the sum of the two. So we can calculate all kinds of cool things. We can calculate the K and the whatever. What else can we tell you? That's probably enough. You don't want to know anything else, right? We'll do number 10. Oh, you do want to know something else? No? Justin says he doesn't really need to know anything else today, but he understands that he will know something else before he graduates from the program. Whatever that might be is a different issue. The equation for the motion of a particle is, so y 5 cosine 8t. Fine. All right. Where t is in meters and y is in meters, t is in seconds. Graph the equation. Find the distance from the horizontal at time t equals pi over 4. Okay, well, we'll do that first. So y pi over 4 is equal to 5, the cosine of 2 pi. Well, the cosine of 2 pi is 1, so this is just 5. Okay, so we did that part first. Now we're going to graph this. Well, what's the period? Well, the period is 2 pi over 8, also known as pi over 4. So now we go and we make a graph of an equation of a cosine function. So there's my cosine function. It starts high, it goes down, it comes up, it goes down, it goes up, and it goes all the way up to 5 and all the way down to -5, and it repeats itself every pi over 4. So this would be pi over 4, that would be pi over 2, and now I don't have to do the other calculation because I know at pi over 4 I'm going to be at 5. So that's why I said graph it first and tell me what it is second. Okay, so I didn't necessarily have to go the other way. And with that, we're done with chapter 11, unless we want to do something else. Okay, why don't we do problem 14 on page 442. Okay, so I'm doing 14 on page 442. All I have to do is make it look like 4s and I'll be all set. All right. A alternating voltage has a peak at 220 volts and a frequency of 60 hertz. Frequency is 60, which implies that omega is 120 pi, and it has a phase shift, theta, of pi over 4. So I can write this as peak of that. I can write it as a cosine function or a sine function. Write the equation of the variable. What do you think? Should I write it as a sine or a cosine? Sine. Sine 120 pi t plus pi over 4. All right. And write the equation of the voltage. Okay, I got that. Voltage at times t equals, that's the A guy. All right. So I look at it and I say, well, the period is 2 pi over 120 pi, giving me 1 over 60. And I see that the phase shift is going to be, we'll use a different guy. The phase shift is going to be pi over 4 divided by 120 pi, which is 1 over 480. I think we did this before. Didn't we just do this? All right, so now I'm gonna graph it, and I'm supposed to graph it for 2 periods. Okay, so it's a sine wave. It's going to start at 0. It's going to go up. It's going to go down. There's 1 period. It's going to go up. It's going to go down. There's 2 periods. I make it up to 2, 2, 0. I make it all the way down to minus 2, 2, 0. And then my, oh bummer, I forgot the phase shift. All right, so I'm going to have to come back here. There we go. I come back here to minus 1 over 480. And now I'm going to go up. And I'm going to go down 1 cycle, 2 cycles. Okay, so that's fine. So this is going to be 7 over 480. That was good. 7 over 480. And over here I'm going to be at 15 over 480. Okay, and I'm going to go all the way up to 2, 2, 0, and all the way down to minus 2, 2, 0 volts. Okay, questions about that? No? All right, you say so. Yeah, just keep your wits about yourself. Don't make anything up. Everything stayed the same, just a word problem, not a real problem.